This is recording. I forgot to say something, guys. Always we forgot something. This video I posted in my YouTube channel. Okay, that you can see today. You re-watching again if you want. Okay, so now basically suppose que I declare whatever. This component is 0.1, 1, 1, 1, or 2, 2, 2, doesn't matter what you call. This is the component 2. And now you plug it in, plug it in, plug it in. PQ segment distance is square root, big square root, and you're subtracting negative 1, and positive 4. Let me do it step by step. Negative 1 minus 4, right? A actually is negative 5, and negative 5 squared is positive 5, positive 25. Plus y2 is 2 minus 6 is negative 4, per square is 16. Plus C2 is 3 minus 2 squared, que es 1. Minus 2 squared, que es 1. Actually, this is a square root. This is 5 squared 25. 25 plus 4 squared is 16. Then 2 minus 6 is 4. Negative 4 per square is 16. Positive 16. Plus 16 plus 3 minus 2 is 1. Square of 1. Yeah, you put together, it's 42, no? 42. Okay, it's 25, 17, 2, 1, 42. Okay, it's square root 42, and square root 42, and you know, and decimal approximation is to have some idea, because 42 sound weird, is 6.48. And we can double checking this distance in GeoGebra. In GeoGebra, give me a segment and also give me the distance. Okay, I suppose that everyone understand very well this, you know? This is straightforward, right? So you are familiar with the distance formula, maybe in 2 dimensions. Now we're extending 1 dimension more, I can see. That's it. Okay. Entonces, you want to see in GeoGebra? Okay, sorry. You let me know, guys. I can share GeoGebra. Oh no. Okay. Do you see GeoGebra? Good. So when I did a segment PQ here in this panel. By the way, this panel is the algebra panel. It's called an algebra panel. It's a 3D graphic panel. You see the segment PQ and you see the distance in decimal approximation, okay, 6.48. Boom. Final answer. My answer is good. No problema. Do you understand very well? Super. Okay, let's move on. I want to take advantage the distance formula to define a new mathematical object. Okay, look. Oh, wait. Again, I want to come back to the whiteboard, guys. Oh, whiteboard. Okay. Yeah. Okay. 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 Do you see my whiteboard? Okay. Yes. Okay. So now I propose you find the equations. Suppose this is the distance formula. Distance formula is distance between PQ. Okay, but in that case, I want to do the equation for the sphere. sphere. A sphere. And a sphere, by definition, bueno, a sphere is like a ball, no? But no solid. Ball is the hollow, so it's only the peel of the ball, no? And basically, is by the definition of the sphere is the geometrical object equidistant with the one specific point. So we need to define the sphere. It's similar to the circle, but a sphere in 3D. We have center. Entonces, normally I call algebra, the coordinate of the center h comma k, no? Or h comma k. I suppose you remember now we have another component I want to call L. H comma k comma L. It's a center, and the radius is distance. Is the distance from the center to any point on the sphere. Que is r, little r. So basically, using the distance formula, well, we have a square root. I suppose any point on the sphere, like x, y, z in general, no? Entonces es x minus h square. So you need to be familiar que h is the x component, the center, and y minus k square plus z minus L square. And this is equal to R, que is the radius. If you square both sides, to put elegant, you have x minus h square plus y minus k square plus z minus L square equal R square. And this is the equation for the sphere, of course, in standard form. Okay? To understand much better, I propose one elegant example. You have two spheres. One sphere, this is the example of the sphere. Example. Suppose we have this. X plus 2 square plus y minus 3 square plus z minus 2 square equal 144. And immediately you can identify, wow, this is a sphere. A sphere in which the center is located at the point negative 2, 3, 2. Remember, guys, in the point, we have different signs for the equation, no? Because the equation contains minus here. And this minus affect. Actually, see, the component h is negative 2. When you plug it in here, double negative becomes positive, no? Therefore, you take mechanically the same number but opposite side to define the center. And the radius is square root 144 because this is r squared, look. And it's a 12. Okay, so I identify perfectly. Well, my sphere is it has the center at the point negative 2, 3, 2, right? And the radius 12. Nice. This is the big. I want to call big sphere. Big sphere. Because the radius 12 is big. However, we have another small sphere in the example, inside the same example. We have another sphere. Okay, this sphere is not given in standard. It's given in general, I don't know, in crazy form. Okay, something like that. X squared plus y squared plus z squared. How you identification que es a sphere? Well, it's important. I promise in one moment of the course, in this chapter, of course, I explain the basic rule to identification of the surface. But in this case, I anticipate something. I anticipate when you have completed X, Y, and Z, and both and everything is a square, it's a sphere. Or no, exactly, sphere. It's family of the sphere. Okay. When you see the X square, Y square, and Z square, it's a sphere. No, not exactly, because the coefficients are different. Entonces es another thing. Pero okay, in this case, the coefficient is 1. If the coefficient is 2, 2, 2, or 3, 3, 3, it's a sphere. Okay, so now what should I do? Well, you have to express it, this equation, as a standard, no? To understand, because I don't understand anything. It's not clear for me, this. So now to express a standard, well, you move everything, no. You, for example, you copy x squared, you group in x squared. I move 8x to the left hand side, and you complete the square. This box means y is a one artificial number introduced to complete the square. Now plus 4y, I move negative 4y to the other side like a plus and complete the square and the y bar. Plus c squared minus, I move a c que es positive to the left, minus c is c, plus another box. Entonces, in the right hand side, I keep negative 20 plus 3 boxes. The boxes for the 3 dimension. 1, 2, 3 boxes. Okay, ready. Now, remember the rule. I suppose you remember, you take that number, gets 8. I don't care, the sign is not important. Divided by 2 and square. 8 divided by 2 is 4, square is 16. So the number that I introduced artificially is 16. 16, right? Now, likewise, 4 divided by 2 is 2, square is 4. It's a coincidence. And 8, well, I did before, it's 16 also. In order to doesn't affect my equation, you put 16, 4, and 16. Okay? Now, factorization. The factorization, this trinomial is a perfect square trinomial, entonces es x minus 4. It's important to understand this 4 comes from for the square root 16, and this negative sign is because the first sign is negative, because the second always is positive. Remember, I introduced this number artificially, I never put negative. Plus y plus 2 squared plus z minus 4 squared equals something, equal, well, this is, minus 20 plus 4 is 16, or negative 16, and 1 negative 16 cancel out with the 1 positive 16. Beautiful, that's 16. Excellent. That's I have, wow, in this moment I have the standard equation of the sphere, and the center of this sphere is located at the point 4, negative 2, positive 4. And the radius is square root f4. Very well. He said f4. David, no? David tried to find your point for the participation for. Okay. Now, what is the, okay, Professor, I understand, but okay, what is the point? What is the point? Well, we have two spheres. We have the big one, and we have the small one. Small sphere. I want to investigate if the small sphere is completely inside the big sphere or not. So we have different possibility, no? We have the possibility, suppose the big sphere, the big, and we have the small. and maybe the smallest no totally inside or no partial, I don't know, right? This is the idea. Okay, so I propose one strategy. One strategy. The strategy is you have, for example, the center of the big sphere. Okay, there you go, the center. You find now the center of the smaller sphere, maybe. You have two centers. This one and this one. Okay, and why no? Why no? We compute the distance in between the center. Okay, this distance is possible doing. Now, if you adding the radio of the other, so this is the radio. Okay, the radio by the way F4. Okay, 4 F4. If, for example, this distance is the radio for the big sphere is 12, no? It's 12, look at that. It's 12. And this radio 4, so the only information we need to compute is the distance between the center. And verification, see this is totally inside. Oh no. Okay. So one more time, we use a distance formula and between center and center. Okay, is square root. And you're subtracting the x component. Look at that. 4 minus 2 is 6 squared. Do you follow me? Plus negative 2, positive 3. Remember, you're subtracting. It's 3 minus 2, 5, no? 5 squared plus and 4 minus 2 is obvious 2 and 2 squares is 4. Okay. The answer, right? The answer is square root 65. Okay, and decimal approximation. It's important the decimal approximation, guys, because when you have to have geometric idea, because square root 65 is not clear for me. This is 8.06. 8.06. Okay, that's a basic. I need to prove somehow. Suppose that the hypothesis, okay, the small sphere is completely inside. When the number go first, the big sphere. Let me try. I try to prove, okay, 12 hypothesis. I suppose yes, the small sphere is totally inside the big sphere. So I prove that 12 is greater than 4, the radio plus that number is 8.06. Wow, no good, because this is 12 greater than, this is 12.06. Almost. This idea is incorrect. This idea is, look, this is my sphere. Okay, the other sphere is a little bit outside. Do you see that? Now, to verification this super fantastic, I try to do, so you have time, no? And GeoGebra, no? I create a script for this lecture of the GeoGebra. Illustrate. Do you understand this? No, the GeoGebra part. So far, do you understand completely the square? You say, yeah. Valentin. Okay, Valentin. Okay, just let me try to do my best. GeoGebra. I try to find it. Oof, again, it's frozen. GeoGebra. Carajo. Okay. I don't know exactly what's going on. Okay, open that. Open new script. Open this one. The 3-1, no. To sphere and distance. Boom. Boom. Wait a second, guys. I try to do my best. Okay. Conic. No. Surface. Sphere. Okay, there you go. Boom and boom. Okay. And this one. Okay. And this no, and this no. Okay. Okay. I am ready to share the screen now. Do you see the GeoGebra script or simulation? I don't know what is this segment. Okay, let's do it. The big sphere is this one. Boom. Wow. I can change the here when you are doing your script in GeoGebra, little by little you learn. You click here and you go to the settings. In the settings, you can adjust the transparency or opacity. Let me see what is the name. I don't remember. Color. Here you graduate or opacity. In this case, I put not too bold. I put opacity small because I want to see inside the big sphere. And this is the small sphere. Well, I put another color. And let me see. This is the center of the small sphere. No, the big sphere, sorry. The first one. And the second is this. Center. Do you see? Fantastic, no? And you see the intersection and the sphere exists. Yes, this curve. Bam. So you see clear like a water now. Our conclusion that we found is the small sphere is not totally inside the big sphere. Any question? Do you see or no? No. Natalie Rivera, what part you do see no? Natalie, activate the microphone and ask me directly.
No, I was saying that we had no question.
Okay, thank you. Okay, entonces it's clear. Let's move on to the most interesting topic. Most interesting topic is vectors. Okay. Whiteboard now. Do you see whiteboard? Do you see? Excellent. Erase the whiteboard. Okay, vectors, guys, vectors. Do you see now in this calculus the extremely importance of the connection with the vectors? The vector allow us to understand much better the multivariable calculus. So vector is represent visually. So vector, well, you know vector because in physics, maybe you took physics, right? Or no? Yes, okay, super. Better. So you took it's better. So you don't. Okay, vector is a mathematical representation because in the real life you have, for example, different quantity. It's impossible represent like a scalar because classical example, velocity, acceleration, linear momentum, electric field is vectorial quantity. Therefore, the representation is using vectors. So the vectors have two important things. It's a magnitude, and the direction. And you can represent like arrow, no? It's important. You have tail and arrow. The length of this arrow is the magnitude. And the direction, well, the direction we can represent in different way. You can represent like an angle maybe with respect the x-axis, theta, or using UniVector, okay, I want to explain in a few seconds. It's the most common way using UniVector. Okay, entonces you are aware that the vector have two parameters, magnitude and direction. Okay, entonces now suppose the notation that we are using, here is using angular bracket. Let me say something. In GeoGebra, when you want to write vectors, you write no capital. It's supposed to be lowercase. Si es capital B, it's a point. Si es lowercase, automatically GeoGebra understands it's a vector. But on the paper, no. In the paper, you put that symbol, vector, right? And we're using angular bracket. For example, 3,2, 1. Okay? And what means that? Well, this is a component X, this is a component Y, and component Z. It's similar to the point, but no, because actually this is a position vector, and the position vector, let me try to do my best by hand, but in GeoGebra we are doing better. This is 3 components here, 1, 2, 3. This is x-axis, 2 here, 1, 2, and y-axis, and 1 in the z-axis, and we connect it like a point, exactly the same. But the problem is that you connected this point and the origin like a vector, and this is called position vector. So position, when you're talking about position vector, is a vector that connecting the specific point, exactly we are doing before, and the origin, and it's a position vector. Okay, entonces now, pero we have another notation que I like so much, que es de Hamilton notation. The Hamilton notation define 3 univectors que en 3D es the classical trihedral. When you're talking about trihedral, is the 3 vectors because are important for some reason. Okay, and the x-axis here, x-axis, y-axis, z-axis, and in x-axis we have the vector I. The vector I. Look, this is a notation. I hat. What mean I? I means the vector 1, 0, 0. It's the univector in the direction of the x-axis. Positive. We have the vector J. No, green color. Okay, it's okay. J, que is that vector in the same direction of the y-axis, que is the vector 0, 1, 0. And we have in blue color here the vector K. Okay, vector K is the vector 0, 0, 1. And this is the trihedral. By the way, this is orthonormal, orthonormal. Okay, what means that? Ortho indicate 90 degrees. So the angle in between this vector ij and k are 90 degrees. It's obvious. And normal indicate the second part of the word. Normal is the univector. So the magnitude of this vector is 1. That if you go, for example, you compute the magnitude, Professor, but what is the formula for the magnitude? Okay, too many information. Mix it together. Okay. After this, it's the univector, and this is trihedral. It's the 3 vectors, important, extremely important, que is like orthonormal trihedral. Okay, and we're using the Hamilton notation. to represent this vector. So this vector B, we can represent, no using angular bracket. No, you. Either way, I prefer angular bracket frequently. But another way you see in the book and you see in the article or something is 3i plus 2j plus 1. Okay, you know, when the coefficient is 1, it's invisible. But okay. This is Hamilton notation. This is the same thing. It's equivalent. It's equivalent. So let me reinforce the idea about ortho. Ortho is 90 degrees. When you see orthogonal in mathematics means que two vectors form a 90 degree. Orthogonal vector. In this case, obviously, right? It's the corner of the origin here. And normal indicates que es UniVector. So now I want to anticipate que the formula for the magnitude, okay, by the way, magnitude is actual value. Okay, another book using this notation, magnitude B, using double bar. Either way, I prefer not necessarily double bar, but I understand that this is not actual value. So actual value 2 is 2. Actual value negative 2 is 2 also, no? But this is magnitude of the vector, is a square root. Each component separately, you know, 3 squared plus 2 squared plus 1 squared. This is square root 9 plus 4 plus 1. Square root 14, and you put in decimal. Either way, this is not important. Okay, in this case, the magnitude of this vector is obvious. The magnitude of I is 1. Is equal magnitude J is 1, and magnitude K is 1. That is the reason que es normal. Orthonormal. O sea, trihedral, que es 3 vectors, que the angle in between them is 90 degrees, orthogonal. And therefore, this vector, the magnitude is 1. I promise you see in another moment of the another trihedral important, que es orthonormal basis. Okay? Okay. Too many names, eh? I understand que too many names, orthonormal, Hamilton notation, the classical angular bracket notation. Okay, let's do an operation with the vector. So far, any question, guys? Don't hesitate. Remember, I am no monster. I am teacher and you, no question. Alejandro dice no question. Okay, good.
I think for me that last part was a little confusing.
What part? What part?
The lines.
What part? What part is confusing, miss?
It's right here down here where I think it's just a different type of notation. Where you have the little brackets. I think that's what confuses.
Yeah. What do you prefer? Either way, I explain both ways. The most common in my lecture is the angular bracket notation. They said you define trinomal 3, 2, and 1, and this is the component of the vector. Okay, and the vector, que es position vector, is the vector. Remember, the vector is an arrow, in which the tail of the arrow is the origin 0, 0, 0, and the arrow is the point 3, 2, 1. There are no more secret behind this. You understand? No. Don't try to find. No. This is straightforward. Okay, now operation. Well, no, operation no. We have another kind of vector. Que is the vector. So are you clear? Position vector, right? But we have another kind of vector, que is the vector between 2 points. So the vector between 2 points. Que is no position vector. So what is the idea? What is the idea behind this? We have 2 points. Here, for example, I have 2 vectors. 2 points, sorry. The point Q and the point P. And we define what vector in that direction. Entonces, bueno, okay. Entonces, what is that? Bueno, suppose que you have the vector P. Okay, the vector P, not the point P, sorry. Okay, the point, let me try to find here, is -2, 1, 1. And the vector, not the point Q, okay, the point 2, -2, sorry. A ver, no, 2, 2, 2. 2, 2, 2, -3 and 4. Yeah, I want to find, this is important moment, PQ vector. Okay, it's a non-position vector, because position vector is this vector or this vector. But this is a vector in between 2 points. But it's super easy. What is the formula? Well, the formula is subtracting. You're subtracting, for example, x2 minus x1, comma, y2 minus y1, comma, z2 minus z1. Pero who is z2, who is z1? Bueno, I suppose que si es the vector in the direction PQ, Q is the arrow. Ah, no, sorry, it's a vector. Hello. This is the confusing part for me. This is PQ. So PQ. I did well. No, SQP. SQP because I suppose it's QP. This is important to be aware of this notation. P represents the arrow. Okay. And Q is the tail. And so you are doing, for example, PQ is in opposite direction and PQ is minus QP. Right? Entonces, you subtracting, you call P. This is X2, Y2, C2, and this is X1, Y1, C1. You call 2 the arrow. Entonces es basically -2 and subtracting 2 es -4. Coma. 1 minus, okay, no, yeah, 1 minus -3 es positive 3, entonces 4. Es 4. Coma, 1 minus 4 is -3. Okay. For example, if you want to find, this is QP. Consider que the direction, the arrow is P. Suppose PQ is completely opposite sign. It's 4, -4, and +3. Do you understand this idea? Because I don't explain very well. I make it. Okay. I see. Okay. Conclusion. Vector between 2 points. Important. We are doing every day. Vector between 2 points. You define one direction, and the direction is from Q to P. In other words, the arrow is P and the tail is Q. So now you have the component of the point PQ separately, and you're subtracting. But what's subtracting? You're subtracting the arrow minus tail. That's it. So you want to find opposite direction. Well, okay, no problema. In opposite direction is subtracting, but in different way. Okay, clear? Clear or no?
Yeah.
No? Yeah. Oh, okay, super. Now, let's see operation with the vector. Maybe you know that, but I need to refresh your memory, no? I need to refresh your memory. Okay, the first operation that we are doing using vector is scaling. What means scaling? Well, scaling is multiplication by scalar. Suppose you have a vector B and you multiply by 2, que 2 is a scalar. Entonces now when you multiply by 2, the magnitude is duplicate, affected by 2, but the direction, no. The direction stays the same, right? This is multiplication 2, que es scalar, no vector, time b, que es vector. Suppose you divide by 2, well, this is a smaller vector, b divided by 2. Okay, this magnitude is half of this magnitude. I try to do my best. And so on. You multiply by -1. Yeah, you can multiply by -1 to see we have a negative b. This is the same magnitude, but the opposite direction. In this case, moving, suppose, hypothetically, suppose that this vector is the original vector, que es 3, 2,1, right? This is b by definition in my problem. You want to find 2b. Okay, super, algebra. Is multiplied by 2, component by component. Is 6, is 4, and 2. Okay? Minus b, well, divided by 2 is the same. Is -3, -2, and -1. Super. Scaling is super easy, straightforward. Now let's do addition, plus. Addition and subtraction, but I want addition first. Add, addition, to vector. I want to explain geometrically. Yeah, I want to explain algebraically. Okay, suppose you have two vectors. Suppose the vector 8 and suppose the vector b. Remember, in GeoGebra, we're using lowercase, but in the paper, no. In the paper, I like to put capital in the vector, right? If you want to compute the addition of the vector, you apply the parallelogram rule. Okay, you apply the parallelogram rule, and this vector, okay, connecting this and this, is a plus b. Okay, if you want, you call C, because it's another vector. Algebraically, well, let's do it. Suppose the vector A, okay, is the vector 2, 3, 1. Suppose the vector B is the vector -1, 4, and 0. And the vector A plus B, I want to call C. You adding component by component is 1, so 2 minus 1 is 1, 3 plus 4 is 7, and 1 plus 0 is 0. There's 1, sorry. Super easy, no big deal. In this case, I can see I'm using the angular bracket notation, but some people get light, we can use the Hamilton notation, I 7j plus k. Either way, subtraction now. I suppose that everyone follow me, no? Subtraction. Subtraction is similar. There are two different ways to understand subtraction. Geometrically, and let's do it geometrical, and let's do it algebraically, no? Suppose I have a vector b again, similar sketch, and a vector a, similar sketch. Don't use matter the with notation. So you're using a notation. The notation is not important. See, you prefer Hamilton, Hamilton. See, you prefer angular, angular. Okay. Focus on the subtraction. Subtraction is, is a particular case of the addition, no? Suppose I want to find a minus b. So you need to define minus m, and subtract a minus b. So one possibility is you scaling b like a minus b. So this is minus b in opposite direction. And now ready to add using the parallelogram rule, exactly the same we were doing before. Bam, 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 bam. And this is my subtracting vector. In that case, a minus b. This is one possibility. But I like another possibility. Okay, it is when you subtracting geometrically, you connecting a and b arrow and arrow by the segment. You see? And what is the tail and what is the arrow? Well, the tail is the minus m que say. And you see that vector and this vector is the same because the important information in the vector is magnitude and direction. No, you can translate a vector in the plane or in the space and the effect is the same. Okay? Do you understand the idea of the subtraction? I like this way, guy. Yes, okay. Entonces, algebraically, suppose another example que es giving a vector, este vector 2,4,6, and the vector b is the vector 4,8,12. I don't know, in this example is 12, and you need to find a minus b. Okay, a minus b, entonces subtraction, ¿no? Es 2 minus 4 es negative 2, ¿no? 4 minus 6 is negative 4. And this is 6 minus 12 is negative 6. Wow, super easy. Addition and subtraction, no problema. No problema. Okay. Valentin participate very well, and you appreciate that, Valentin. And David, okay, they are multiplied the vector. They are, yeah, of course, they are multiplication. Of course. You want to anticipate multiplication. Of course, there are two different multiplications of the vector. Yes. Okay, so far no problem. Okay, entonces now I want to explain in detail UniVector now. UniVector. Important, extremely important UniVector. Suppose. Find the UniVector in the direction of the vector C. Suppose que is given in the problem one vector C, que the component for this vector C is 2, negative 1, negative 2. Okay. This is the component is given in this. And I need to find UniVector. So the notation that we are using, guys, is this. You put unit, entonces you put C parenthesis, UniVector. Find the UniVector. And the UniVector by definition is one vector que the magnitude is 1 and have the same direction of the original given vectors, right? Entonces, super easy. You compute the magnitude of the C. Que es square root 2 square plus negative 1 square plus negative 2 square, ¿no? Entonces es 4 plus 1 plus 4 is 9, square root 9 is 3. Okay, this is the vector C, the magnitude is 3, and the UniVector in the same direction. When you scaling, and you divide by 3, so now divided by 3 is 2 over 3, negative 1/3, negative 2/3. I guarantee you 100% that this vector have the same direction of the vector C. However, the length of this UniVector is equal to 1. Do you understand very well this or no? No? Confusing?
That is to find the magnitude?
Yeah. Look, let me prove. Pero aromática, this is the procedure. Suppose I find the magnitude of this UniVector. Magnitude of this vector is 2/3, negative 1/3, negative 2/3. Suppose I want to find this. Magnitude is a square root. I get the process. Okay. But don't worry. Some people do not get. So you square this, 2/3 square. Plus 1/3 square, negative 1/3 square, sorry, plus negative 2/3 square. Okay, let's compute it here. Surprise, what is the answer of this? Well, this is 4 over 9. This is 1 over 9. And this is 4 over 9 again, right? We don't care the sign because we square become positive. And you add in this guy. 4 plus 1 plus 4 is 9. It's 9 over 9. Wow! It's 1. It's UniVector. It's UniVector. However, for sure, 100%, the vector UniVector, que es this guy, have the same direction of this, because the only thing that we are doing is scaling, multiplication by scalar, or divide by scalar. Clear now? Clear now?
Yes.
Yes.
So do you always divide them by the magnitude, or are there times where you multiply
That's it.
it?
That's it. End the story. Divided by magnitude. You want to find UniVector?
Oh, okay.
You find the magnitude of the vector that's given, divided by this, end the story. And you get the UniVector. And the UniVector, the importance of the UniVector is que it's a vector short, but give me the same direction of the original vector. So give me information about direction, no magnitude. Magnitude is 1. When you're talking about UniVector, it's 1, for sure. Okay. Somebody say, Professor, and no multiplication. Well, yes. Multiplication of the vector is super important. I want to introduce in the 10 minutes that we have the idea, but the basic idea for the multiplication. Bueno, we have two. I anticipate we have two kinds of multiplication. Guys, extremely important for me. Not only formulas, because the formula you can find in the book, sino interpretation for this. Everything we compute, you need to understand what means that. Interpretation, everything. Interpretation. The first multiplication that we study is dot product. Dot product. So we have two kinds of multiplication in the vector. The first one is dot product. Okay, let's do it. So now dot product is the notation is a vector dot product B. Entonces es importante que in the scaling you put 2a. Actually, it's multiplication. But if you put period here, but this is not to ball like that. When you see ball, it's dot product. In this case, omit, or you put the period, but no to ball. Okay, so what is the definition for the dot product? Well, the definition is, suppose que a vector have 3 components, because in the space, a1, a2, a3. And b vector, again, have 3 components, que es b1, b2, b3. And the dot product is the multiplication, but multiplication component by component. You multiply a1 times b1, this times this. So you match it, component by component, multiplication. Plus a2, b2, plus a3, b3. Okay? This is dot product. This is definition. The mathematician created that. This is the definition. And that's it, end the story. Entonces, what is the interpretation? This is another thing. Okay, we can prove, but no, because proof is too long. The people who want, because I suppose somebody here it's important for me to understand not only your names, you know, your major, what major you want to, si es engineer, si es scientific, si es mathematician, because the mathematicians want to prove everything, no? So for example, another formula, no definition, mechanical engineer. No, guys. You, I appreciate so much, Berenice, que you email me, engineer, but what kind? Civil, electrical, industrial. Okay, no, don't make a noise. Don't make a noise. Environmental, good. This is the future. Okay. No, civil. Okay. No, now. You email me and you inform me your major, right? Nobody is mathematician or physics? Mechanical engineering. Okay, another formula for the dot product is okay, another important formula. Magnitude A multiplication magnitude B. That this is multiplication, but this is regular multiplication, not dot product. Cosine theta. And who is theta? Oh, theta is the angle in between the vectors. So suppose that the vector A and the vector B is something like that. And this is the famous theta. This is another formula. No definition, it's another useful formula for the dot product. Okay? Then we have no time. I promise que next time, I don't know, 5 minutes, 4 minutes. No, stop. No, to say next time we are doing example to understand what means the product. You don't understand very well what is the reason que I multiply the vector. Okay, guys. So now I enjoy this. Any question you have? Let me see. Let me try to stop sharing everything. Stop sharing. Do you see my face now?
Yeah.
Yeah. Okay. Any question you have? No. Okay. So now, try to be on time. Any lecture, because normally I don't know why the first part of the lecture is the most important. How do you access to the homework? Okay. I appreciate so much. Okay, you today, not tomorrow, go to the MyLab website and you create the account, your own account, your own credential, username and password, using the course code I provide in the syllabus. This is hard for you or is clear? You are doing several times this, no? I suppose. Clear. Okay. And now, you, in this moment, is waiting for you 4 homework and 1 test. Pero no, this is due, I don't know. Let's do, you see the due date I posted. Entonces, take advantage of our help. José Alegre and me in the tutor. Yeah. Do you have office hour? Well, okay. Listen. Suppose que Tuesday and Thursday is not good for you because you are working. I don't care. No. Anytime. Okay, you have problem, you email me, Professor, I am doing that problem. Yeah, I don't understand or I don't get. So you send me a screenshot of this specific problem, because so you say no, the problem number 4 and the question number 2. No, because the question, this question number 4 and the homework number 2 for you is not exactly like me. It's different for every student. So this is not good information. You make a screenshot, you send me, I try to solve it, I send to you the solution. But okay. Pero no, don't abuse with this. One problem, 2 problems, 3 problems, 4 problems is too much. Okay? Because it's your homework, not my homework. And this is your point. Okay. Anytime. You email me with the question that you want I solve for you. Yeah, I solve for you. Okay? Have a nice day, guys. Bye-bye.
Professor,
Thank you.
Somebody
want to ask? Go on.
Yeah, a question for the final. Is it just 100 points or is it 200 points?
No. It's no 100 ni 200. It's in the middle, depending the way que I assign. So you suppose que you are doing perfect, 100. It's a minimum. But you are good participation and attendance, so you have 4 points.
More than 100.
This formula is my secret. Okay.
And then for